Hi, gang. I'm back again after a very short break of only 2 days because, I want to do a follow-up of my last video. I was listening to it. You have to proof it, and I heard something I missed, and then the next day I looked a few things up related to it because I was curious, and I found some things that should be in there. So this is a part 2. I even wore the same shirt for the continuity of it all. I'm doing it quickly within 2 days, and it should be worth your time if you like the first one, which is a stretch. So let's go anyway. And we always start out by looking at the thumbnail, and in this case it gives us a sort of a script. Another bombshell shocker. You've never heard any of this, etc. and so forth. Well, what can I tell you except this? Got to remember this. This is actually worth me. You got to do this and gyrate. But we'll keep it to a minimum, but it's required, isn't it? So, okay, what are we talking about? Light pumping found in GR, General Relativity. That's what we were just talking about. That there was nothing in there that could be found in General Relativity. There's no intuition there. There's nothing there. It's so limited. You can't do anything with it. It's all been done before, and we know all about it, don't we? So we're going to go over that briefly and find out what the difference between Google and AI, Grok, how it makes things so much easier. And you can ask the questions that you couldn't figure out the first time around 12 years ago, whenever that was, 14, I don't know. And it's just a simple question pulls it right up. Then we're going to talk about secret metamaterials. Then we're going to talk about electrons as wannabe hydrogen. And that's what I forgot last time. And did you know, folks, that not only are metaphors fun, but your glasses could kill you? See that? That could kill you. Stay tuned and listen to that little yarn, which was an extension of actually what I've been saying for quite some time. Okay, next, hose mad chat. Now that's a thing I heard, and it just made me laugh and laugh. I don't know why. Ridiculous, more than necessary. And it was Ashton Forbes, and it was, I don't know, it just stuck with me. And then, the next day I see some mad hoes on the internet, so we'll address them too. Very end. And then repulsive gravity is at the end. And now that sounds like your typical BS, doesn't it? Well, it comes right out of GR, which I just found out like yesterday or something. And after listening to myself, proofing myself to make sure my sound didn't go out mid-recording. So you have to listen to yourself. And when you do that, you actually listen. And then you think a little bit ahead maybe about something else. And that's what happened here. And it turned out to be a big surprise, and I would call it a winner, but definitely something to follow up on immediately. It flows right out of it. And if you like that and you're interested in, if you like Davis and Weinstein talking about this stuff and GR and what can be done and what can't, then you're going to want to maybe listen. So, what happened? They're talking about GR, and I have my theory on this. You all know that. And if you don't, look around, look below into the description, and you'll see my manifesto, whatnot. Look at the other videos. And for years, and even going way back to the beginning of this thing with me and my thoughts on it, is the Eddington and Einstein stuff. Now, I'm of the opinion that light affects gravity somehow, and that's going to be your secret to your anti-gravity, your UFOs, your future, free energy, your old propulsion, whatever. Fill in the blank. all the core secrets, all this and that. I think it lies there, and Eddington and Einstein provided some insight to me on that, and everyone else, of course. I'm only following their path. And as you know, most of you, many of you, Einstein's predictions, or Einstein's work, had caused Arthur Eddington, this is roughly speaking, to predict that gravity, a massive body, should bend light. Okay? And then they proved it, and I think there's movies about it and everything else. So you don't have to listen to my poor retelling of it. And I used that for years as saying, well, light affects gravity, gravity must affect light, vice versa. Just a logical thing that should have been explored, and why don't we know this and all that. But I was only thinking of it in terms of, conservation of energy and symmetry and cause and effect and these generalisms we have in physics. And, of course, I don't have a lot of sites. I don't have a lot of authority on all that. It just makes sense. Really doesn't need that much. But it doesn't have that much, shall we say, persuasive value to people like Davis and Weinstein talking, because they're getting into the specifics, as you heard, with theta and bundles and all that stuff. So, a thought occurred to me, as it might have, it probably did. I probably looked this up on Google alone, 14 years ago, roughly, or 12, or somewhere in that range. Digging around trying to find this, and you can't ask questions on that. You can only think of them and hope your search results will come up correctly. Well, now with Grok, you can, if you remember what you've were wondering about all those years ago, you can ask it again. And now, in light of new facts have come to light, man. So I asked it, the equation, Einstein's equations are what inspired Eddington, and they proved something with it physically. Now, can we look at that backwards, like I want to do? And does the equation say anything like that? And can't you just flip them around? And I would think yes, and the answer was yes. And like, wow. So there it is. I have it linked up. I have these. This is all documented on X, and you can find those threads below. So without describing all that in excruciating details, you're going to find that down there. And well, I have to read this result to you, I guess. Yeah, okay. So here, what you're looking at on the screen and is linked below is my questions to Grok about Eddington and Einstein, just asking them what I just told you. And the answer there is yes. Wow, yes. So you're saying light does affect gravity, Kelly? Why isn't this well known? Why don't Davis and Weinstein? Why isn't that all they're talking about? Okay, because this fits what they insist upon, and it also fits the signatures, and it fits a lot of stuff, including a lot of speculation I gave you last week, and I would just call it reasoning. For lack of a better word, and but this thing took this here thing called Grok took the equation, twisted it around, said yes, of course it does. Why didn't you ask me before? Because I've been through all this on the reasoning side with this thing, but if it mentioned the equation, showed it in reverse, I don't remember that. 'Cause these things are wordy. You don't read everything. But I don't think I ever saw that. So, so all of a sudden, it's, one question later, it's spewing names at me of people and names and papers of physicists that have looked into this little obscurity. And I'll tell you why it's an obscurity and why the Davises and Weinsteins, even at that level, don't see it jumping out at them. And it's really interesting, parallel here to what this crowd likes to listen to, the Maxwell and Heaviside stuff, where Heaviside took Maxwell's equations and sort of rounded them up and made them more usable, to use a very crude expression. Well, ladies and gentlemen, I didn't know this. It makes sense, but I really wasn't on the top of my mind ever. But it makes sense. Of course it does. Because Einstein's equations, the ones we see and the ones normally used, are also rounded up in a similar fashion. If you go back and look at the versions before the final versions, you will see that the finer, again, the equivalence is the stuff that brings out the scalar stuff on Maxwell. Well, over here, it brings out more fine detail that tells you that light does indeed affect gravity. Did you hear that, everyone? I am saying into your ears, providing you links and telling you on Twitter and, X, that your solution's pretty close at hand. It wouldn't surprise me if inside the Pentagon they knew all this. A lot of people knew this, whatever. But you have your legitimate physicists and papers out here, and we're going to look at them a little bit and talk about them a little bit. They come up with, this is their word, not mine, repulsive gravity. So why don't you go look at that? Wow, look at words, look at people like, because I can't read this to all of this to you. I can only hit the highlights. Jan Willem van Holten, I guess he came up with this first, sort of. He was earlier in time. His key papers include the gravitational field of a light wave. Wait a minute. That's newer than I thought. So, he's still around. That's 211. The gravity of light waves, 2018. I meant 2011 before. And these are in European journals, I suppose. The gravity of light waves, the gravity of light. He's got 3 papers sitting right there. And then we have earlier other ones. So he must be the one that's, some of these other people are current too. We'll get to them. Because Grok likes to put things out of order to confuse me. So we had another guy, W.B. Bonner, who in 1969 came up with exact solutions in the Bonner beam and his paper's called The Gravitational Field of Light. And he showed that the gravitational field inside and outside the beam can be matched, etc., and so forth. We'll get to the point, which the point is already made, but there's a couple of sentences in here that really make it nicely. And then I asked Grok to summarize it into a paragraph, which we'll get to at some point. But they, let's see. I'll just read it. And see, I can't think and read at the same time when stuff this deep. So I'll read it so you can think. They show, this is, these are the other ones. We had the Dutch guy, we had Bonner, and then we have these 3 Italian people here. Sparano, Vilasi, and Vilasi, and they're still around. They started out with this stuff in 2010, 2011, but they have a fresh one fresher from 2018, and they keep saying the same thing. We may as well just go and look for that. Let's go and look for that paragraph. I have it lined up. Okay, here it is. Tell me more, Grok. Dumb it down a little bit. Okay, quote, in their 2011 paper called, quote, The Gravity of Light, 3 physicists, Sparano, Vilasi, took a fresh look at this old puzzle. Instead of using the usual simplified math that only works for weak gravity, they used the full, exact equations for Einstein's general relativity. Sound familiar? Their big idea was this: when light beams travel through space, they just don't create ordinary gravity, they also create special nonlinear gravitational waves that act like they have a spin 1 property. In a quantum picture, these would be like massless graviphotons. Okay, that's new to me, but it's all real, and it's just a small part of physics that no one saw yet. These spin 1 parts of the gravity wave can't be removed or ignored by choosing a different mathematical gauge. And they create a repulsive force in certain situations. Which certain situations, I think those are going to be created. Now, if those are real advanced intelligences out there, I think they already created them. Don't you? Maybe? Yeah. They create a repulsive force in certain situations, especially when 2 light beams are moving side by side in the same direction. Okay, that's what your metamaterials does. Okay? Will do. That repulsion is exactly what explains why the old calculations showed no attraction between parallel light beams. It's not a mistake. It's a real effect hiding in the full nonlinear theory of gravity. So, there you go. Now, this next thread here, it just goes in more detail. Pretty much what I just said. Here's a little summary, so let's read this one. In summary, the relevant focus is on exact Einstein-Maxwell PP wave solutions, where the electromagnetic wave sources a co-propagating gravitational PP wave, directly illustrating the back reaction. This embodies the cause and effect symmetry that you described. The curvature, I love this part, the curvature that bends light itself is influenced, generated, and carried by the light. Key references include Van Holten's papers on, quote, the theory of light waves, unquote, and related works on plane wave Einstein-Maxwell systems. Oh yeah, here's this little tweet. Post that I posted it myself and reposted it to the world. There's your GR, Erics. It's in there somewhere, and that's where. In summary, Van Holten stands out for the cleanest, most modern extension of EM planes, blah, 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 directly illustrating gravity, quote, gravity bends light, light bends gravity. They also call it sources. I guess that's a special physics term I'll probably have to remember. But all I want is the dumbed down part. Gravity bends light, light bends gravity. That's how my mind works. Now, all this extra detail is beautiful. Bonner provided the foundational cylindrical exact solution. So it comes out of the math. All right, so you guys can go argue with Bonner next time you're thinking I'm a total loon, and maybe just a half of one, all right? And we're gonna use our engineering chops in this world to improve upon what these people are seeing. We're going to scale it up. We're going to densify it. And we're going to do all that stuff. The body of work is niche, focused on exact solutions rather than astronomical applications. In other words, in some places you can round up. It's just like life, right? But serves as a rigorous theoretical proof of principle. Everyone hear that? A rigorous theoretical proof of principle. Now see why I came on here? Because normally I only have, me talking about common sense into the void, but now we got let me repeat that. What did you say, Kelly? I said a rigorous theoretical proof of principle. That general relativity, okay, now that was a big topic just a couple of weeks ago, treats light and gravity with, quote, full mutual symmetry. Now, even I can understand that. Light affects gravity in some way. That's what I've thought before, but these people are saying, yes, it does, and here's how. And let's see what the next tweet says, because I made a thread of highlighting what all that stuff I went through on Grok. I think I pretty much read it to you here. Wait a minute. Let's make sure we get some of the good quotes if we have them here. Where's the one that I read that one about the PP waves. Let's go back to the Italians. They showed that an exact nonlinear GR, which is the kind we want, the good kind, not the rounded up stuff that's giving you nothing. Light can source gravitational waves. There's that source word again. Light can source gravitational waves with spin 1-like components, not removable by gauge choice, leading to repulsive effects in certain photon polarization. I was just speculating on that. And propagation configurations. I was just speculating on that in the last video with the metasurfaces and the topological fields, also known as propagation configurations. Their work highlights how nonlinearity in Einstein's equations allows gravity sourced by light to exhibit behaviors beyond naive Newtonian intuition. And I would suggest we could also call it naive Einsteinian intuition in the cases where they're using those rounded up equations, which they always use. So, who's naive now, Kay? Sorry. That movie was just on last night. It's called The Godfather. Anyway, I need a sip of water. Now where are we? So that's here's a little quote that says, and this is me on this post saying, and this is the how to go with the why, and we're going to do the why next, and that reaches back to Gary Nolan. And our talk about those crash materials and wavelengths and absorbing and emitting light. And I'll stop here and say we're going to absorb and emit so we can do this stuff so we can create this repulsive kind of stuff here. These light beams canceling each other's gravity out. Well, what else can they cancel out? What else can they repulse? I think we're going to find out. I think that's obvious, and I think we're going to find out anyway, because we got to do it the hard way around here. So now we're still on the why. Let me not get ahead of myself. But again, quote myself saying, there's your GR, Erics. Okay. And moving along now here on your screen, you're seeing on Google Scholar a couple of papers by those Italian fellows. Well, I don't know that they're all fellows. So you can find that for yourself. You know, what is this? Here's one of them. You have to pay for this one. I think this is the one, their breakthrough one. And I didn't pay for it or read it yet. That's a PDF. That's linked below. This one's a freebie, which appears to be an update of that one from 2018. And that I've linked below. That's a PDF linked below telling you, here's the first sentence. See if this helps. In this paper, we will study the repulsive behavior of gravitational interaction in particle physics associated with two specific properties of some of the exact solution of Einstein's equations. The interest in repulsive gravity, or anti-gravity, as it is usually called, goes back to the 50s. Now, they misspelled 50s in the Italian, from the Italian to the English, using the possessive, but that's fine. And it just starts like that. So do you think that's going to be interesting? Of course it is. And these guys are, who are they with? Salerno University, something. I think I remember seeing that, Salerno. So these aren't, just people making stuff up and publishing it on the, on the speculation websites, okay? And Grok would have, wouldn't be using something from there on something like this. I don't think they use it at all unless you ask for it. But it goes into mind-numbing detail, which would take me a while to read, but, it's not... Okay, well, here's some conclusions. Let's see if any of those come out into plain English. Well, they're talking about helicity and photons and gravitational waves. So that's what I was just babbling about, 2 days ago. Thinking it should make sense, it should add up, and here it is right here. Wow. And it doesn't look that it just looks like common sense. Let me just read this, and I'm going to speculate, but I might be wrong, but yeah. Since helicity seems to play for photons the same... Oh, yeah, this is good. I'm glad I found this, because this is going to resonate with a lot of you people. A lot of you people. Listen up to this couple of sentences. However, since helicity seems to play for photons the same role that charge plays for charged particles, two photons with the same helicity should repel one another. This repulsion turns out to be very weak and certainly not observed in a laboratory yet, but it could play a relevant role at the cosmic scale. Yeah, well, it'll add up, and we're also going to make it add up, okay? That stuff floating around in space, that's all over the place, and it just happens to accidentally work sometimes. We're going to take this and fine point it down to the fine points because we're intelligent creatures, supposedly. And if there are UFOs flying around from advanced intelligences, maybe this is what they're doing. If not, it's still worth going down that road until you know. And it might even be useful anyway, despite not being as great as whatever they have. As maybe this is the halfway point to whatever they have. We shall see. But you tell me why they're giving off photonic signatures if they've got something better than what I'm talking about here, which is light affecting gravity. Just like gravity affects light, which Einstein's equation show. Okay, it's weak, weak, and weak, 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 weak. Well, so are a lot of things. So's one or two electrons. You get them going together, you can drive a car with them. Okay, so, you know, a photon's a little weak little thing. Okay, add them up, stuff them in some gas molecules, and you got rockets. The photons are what's driving that process, because when they explode out of there in great numbers, that's where thrust, arguably, I'm not going to say that's what it is, but that's what makes it effective. Other than that, you could just dump 10,000 anvils out of a rocket and it would take off. Well, sorry, that's not going to happen fast enough. You need those photons. You need that force. You need that radiation pressure. It was absorbed in that gas, and now you're emitting it. That's what you're doing in a rocket. You just stored it for a while. So we got off the path there on that side issue. So finishing this this paper, well, you can finish it yourself. You can look at it yourself. Now they're interested mostly, I suppose. Well, they start out talking about anti-gravity, repulsive gravity. All right. Now they throw in some cosmological stuff, because this stuff works on all levels. That's what scaling does. Scale it up, you're moving galaxies around. All right. So, enough. There's a picture of Gaetano Vilasi, PhD, full professor at University of Salerno. So we're not dealing with chumps here like Kelly, okay? Dealing with real people that know how to do those equations backwards, and even more, with more granularity, sensitivity than the usual use of Einstein's equations. So I think we're moving out of that because we hit this thing again. We're going to use thumbnails as little markers. So that was another breakthrough between me and myself. So the next thing we're talking about, okay, now we're back to revisiting Gary Nolan, and we're going to be talking about metamaterials again. Now let's play what he said to refresh our recollection about absorbing and emitting. All right, it's not just me saying it anymore, folks. Let's click.
Been looking at the so-called arts parts materials, and as many others have reported, it is a layered material, and I'll show you something interesting about it in a minute that shows that it's clearly manufactured and not the results of some smelting process. This is magnesium oxide in between here, and it's also very clear, if you look at these bubbles here, that this was exposed to extreme heat, and which would be coincident with the supposed origin being at the blast site of near Roswell, and somehow being part of a catastrophic crash of some object. There's definitely magnesium oxide here. There's definitely bismuth layering in between. Of course, we all know Hal's proposal that this would fit the idea of a metamaterial or a waveguide. I can't speak to that, but it's also, as I said before, it was clear that it was exposed to heat. It wasn't made in heat, and that was the purpose of, and that's why these bubbles are here. These are post-manufacturing heat bubbles from some of the inner molten material. So we actually did run a bit of a reflection, and it does absorb in the right area. I know that this is the same area where carbon dioxide absorbs, but we did do the controls, and this absorption criteria is due to the object itself.
Yeah, it's bismuth. It'll absorb a lot. We went over this, but just had to interrupt them again. It's because if you listen, if you were just casually listening, you might not get the point that bismuth can be adjusted to absorb a heck of a lot more than just a chunk sitting there. Okay, if it's sitting there like inert in its natural state, it's only going to absorb and emit at a certain level. But if you stimulate it which, you have something running through these layers and these skins. And they zap it a little here, zap it a little there, heat it then, cool it there, hit it with electricity there, magnetize over here, and you have a whole host of other wavelengths you can work with. And it will adjust. Let me get on the big screen here. Where am I here? It will adjust. It will open up and close up. And when it does that, the electrons are leaving more or less room to get through for different frequencies to get through. That's basically the simple way of looking at it. So I interrupted.
Is not due to just absorption of the FTIR in the air, because I know people have asked me that previously. So it's actually in the range of what Hal has suggested. It absorbs. What we have not done on the other side is see, well, if it absorbs, what does it emit?
Just like what it absorbs, it's going to emit a whole range. And we went over that last time. And I'll say it again briefly. It's terahertz. What is it? It's the temperatures. You can convert terahertz to temperatures. And those are minus 452 Fahrenheit to 80 degrees Fahrenheit, which is a heck of a lot of the temperature in the universe. So that's a very wide swath of what you can absorb and emit in just one simple element, bismuth. You don't even have to mess with it that much. And the other one, we'll get to that, but I have to repeat it again.
So that's one of the next steps that we'll be taking this material. Getting a hold of multiple examples of that. There's other, let's say, chains of evidence of this material. The last thing that we did on this is basically looking at the crystallographic grain structure. So basically what you're doing is you're bringing in a beam of electrons, and their backscatter diffraction tells you the angle of the crystals. So this is the proof that this was made electronic. This was materially constructed.
Does that look like an intelligent design, folks? Of course. They go out of their way to make this stuff. Let's blow it up a little bit. They go out of their way to make this stuff absorb and emit the whole deal, and the magnesium oxide does some more. And between the two, a conservative estimate is that's 70 to 90% of the light in the universe. Okay, let's go.
Is that the angle of the crystals of the magnesium here are, first of all, clearly perpendicular to the bismuth layering for some reason. Now, these different orientations of the grains that are different colors, basically this is how the electron backscatter is coming back according to the grain, the crystal structure of the grains. I don't know whether that was pre-built in or is a function of the deformation due to the heat or other exposure that this endured. But the fact, though, that it does have these perpendicular grain structures is not something you would expect to see in a smelting process where people have claimed this is the bottom of a lead smelting system. So is the magnesium oxide here, was it originally magnesium, or is it magnesium oxide because it's been exposed to air for such a long time? I don't know. But it's something to look at a later point if there's some larger pieces where we could get to the center of it where it might not have been exposed to the air. But
Gary, I don't mean to interrupt you.
And that's the second one, the magnesium oxide. Probably not from exposure to air, because it's a wonderful waveguide for whatever I mentioned last time, and it's written down and it's linked and all that. It's for visible, ultraviolet, near infrared, whatever it is, the stuff that's not, the terahertz isn't getting. This is getting a big chunk of that. And why are we absorbing and emitting this light, folks? Let's review today. Because we're gonna use it to fool around with making a repulsive gravity, and what was the other thing? How else did they call? Graviphotons. There was another. I'm looking for another phrase too, but it's going to affect gravity some way. We're going to discombobulate it somehow. We don't know how yet. Apparently, whoever crashed their flying saucer does know how. But that's the purpose of all the light manipulation they're doing. If they're using warp drive, why are they doing all this stuff and putting on light shows for shaved apes? Okay, you tell me. Maybe you have a good idea about that. Leave it in the chat. LOL. Where are we? Okay, we can move on there. Oh, yeah, here we go. We're just repeating a little bit of last time. This is Trump saying, so Gary, you're telling me there's 70 to 90%. This is the first time I'm hearing this. I didn't know that. So, yeah, that's what we're telling you. And then we go on and list that stuff. And so when I'm listening to myself on that last one, and I'm proof listening, I realized that, I should have just thrown in, because I've done this before for myself, and, I even mentioned this should be a separate thing. But I didn't think it would blow up this big, because the next thing I looked at was the Eddington stuff. Wow. So I came up with a laundry list. Okay, if bismuth covers this, magnesium oxide covers that, and there's frequencies and stuff listed. I'm not going to go into reading all that stuff. That would bore anybody. You can read it for yourself. And all it is chunks of the spectrum. Once you understand what you're doing, you got to figure out, what are you going to do for what. And that's how the engineering starts. The overview, the design concept, the purpose of what the hell you're doing. So what about the other ones, Grok, that we missed there? What are we going to use? Okay, let's just go through quick. Grok, well, below terahertz. There is some temperatures below 452 degrees, believe it or not. I think it gets to 459. And that is called microwaves, and also called... See how they're inconsistent with this stuff? This is why people don't see that terahertz temperature thing right away. No one sees that right away. Because there's 8 different names for any part of the spectrum, which I would call colder than terahertz is gigahertz. Now they're calling it microwave. Oh, it's just a nickname, And then they mix and match on the centimeters, the millimeters, and the nanometers. Which, it's semi-understandable, but it's all terms of art within certain specialties of the spectrum and what they're used for. So in other words, we don't really have a comprehensive same language other than energy, which is just a number you can stick on a photon. But that's another story. So for the microwaves, we're going to use copper and aluminum alloys, and you can read in detail what it is there. High conductivity, thermal stability up to high temperatures, used in tubes for low loss transmission. Or we can use brass and bronze. Here we are in the Bronze Age, folks. Again, trying to get across the universe. Now we go, well, okay, what's even hotter? Okay, Grok. What's even hotter than Nolan's terahertz and bismuth and MgO range? Well, we keep going. We went below. Now we're going to go above. For infrared, we use this stuff here. Chalco Genide glasses. Okay. We can also use Roman numeral 3-5 semiconductors. Read about those there. We can use silica and polymers for that one too. Now we move up another one to our human being favorites called visible light. And what do we use for that? We use silicon nitride, aluminum nitride, and alumina, organic crystals and polymers, or silica and silicon oxynitrides. So mix and match, folks. This is your first menu. This is your first look at what you're going to be doing now. What's cheaper, what works best with what. What's everybody else doing? How are we going to beat the competition? I don't know. All I know is for ultraviolet, the next one above visible, we're going to look at fused silica, alumina, and alumina nitride again. So there you go. Maybe we can double up on that. Save money on that. Fluoropolymers, e.g. Cytop, whatever that is. That must be a brand name. For our broad UV to mid-IR transparency. Now we got X-rays to deal with. All right, what are we doing for that one? We're going to look at silicon, germanium, and quartz. Or we can select our diamond-like carbon with nickel layers. Nickel comes up in these things, doesn't it? I don't know. Well, that's a meteor. Or we can go to metal-coated hollow waveguides. For example, and then gives you examples from the periodic table. Ni, I guess that's nickel, yeah. Ag, that's not gold. What is that? What is that? I don't know. Au, Ag, I forgot. Especially out of context. Then we get into our gamma rays, which are our killers and the worst things we don't want. The most smallest, most powerful things we know of out there. And for those, we're going to start looking at heavy metals, just like we do for other things now, and like such as lead and tungsten. Or, I think this is probably the way to go, multi-layer optics or crystals. For example, silicon multi-layers. In other words, and I said this to Matthew Shadagas once briefly, and I think he saw it in the chat. I know he did. And he kind of responded. There was only 10 people on that thing. So, yeah, you're going to absorb that and use it for momentum. Because he's saying, what about that? That's gonna, if you're going that fast, it's going to kill you, it's going to come through you, it's going to destroy you, whatever. And my comment was something like, give me all of them you got, Scotty, because I'm using them for momentum. I'm capturing them. I'm wave guiding them. All that is more fuel. But that's a lot of engineering involved there, folks. But that's the concept behind it. And it is, I don't want to say theoretically doable, because it's doable. It just hasn't been done. Because you're going to need very special, quote, multi-layer optics or crystals. But with, the way these metamaterials and crystals and photonic nanomaterials, whatever you want to call them, every day they're double down on something and find something 100 times better for everything, endlessly. And they're going to keep doing it until the end, till we can't do it anymore. So I gave you your why with the GR revelations. No excuse there for any of you squares out there in physics land. She'll look at it and say it's too weak and it's too this and too that. You'll do a drive-by, a bumper sticker overview, and not dig into it. Because you didn't dig into the Einstein equations, did you? It took me to do that and bring that out into this realm. So, what does that tell you? The weakest link. So, this means we shift gears again, because we're looking at the thumbnail again. So, what are we shifting to now? I forget. Oh, yeah, this is something I forgot. About the... Why is that there? Oh, my gosh. You get as organized as possible. And what happens? It gets lost. I found it and it got lost. I found it and it... Oh, please be there. Oh. Well, I guess I found it on the other... Oh, how did I find it? What we're talking about here is... No, I set it up even better than I thought I did. Yeah, okay. Here we go. I just left the search box open, but I did do it. So there's the how, there's the why. We moved on. That got out of place. So we're moving on now to why am I babbling about electrons and hydrogen. There's hydrogen there. And there's a couple of guys that love their electrons, Harold White and Charles Bueller. Not White. I'm thinking of Bueller, and I'm thinking of people that are into the Biefeld-Brown stuff. Because you're throwing electrons around, or you got them stuck on something, and they're doing something, and they're interacting, and they're showing thrust of some kind. Okay? And people getting real excited about that. Well, good, that's fine. I'm going to make an observation here. It's going to sound snarky, nasty, but it's just a shortcut way of thinking. It's going to save everybody time, I think, with the electrostatic and the Biefeld-Brown stuff, and the whole notion of electromagnetic interaction with gravity in the form that's not electromagnetic radiation, the thing we call light, which we know interacts with gravity. We can reason it, and then we can find out that, oh yeah, if you go deeper into the equations, it's right there. So maybe take a look at that instead of the electrons and the electrostatic and the Biefeld-Brown effect. So, all right, these guys were. I want to read you this tweet, this post of mine, and it came up because somebody liked it. It's from July 2024, and I know I posted it before that. But somebody laughs at one of your old tweets. That's what it was. Somebody laughed at it. And I'm like, what did I say back then? It was so funny. And I'll just read it to you. Because I did write it for... All right, it's Drew, who works with Dr. Bueller on the electrostatic. But this also goes for the Biefeld-Brown stuff. And Tim Ventura's making some observation about Drew and Mark talking there. And, when I see these things for the 100th time, after I'm trying to, well, they can read their comments on their own. I'm not going to, spoon feed people. If you ask for comments, read them. All right? So, what do I say here that was so funny in July of 2024? In my opinion, that is a light-matter interaction in the realistic and workable realm of femtometers, nanometers, and terahertz. It is not warp drive or 0 point involving Planck lengths, the smallest known objects, which would be necessary in such things. You'd have to rip them apart and all that, and grip onto them and do all that. Additionally, it is interacting with, listen up, real-world photons that we can measure and work with, not a mere mathematically conjured construct dubbed space-time some 100-plus years ago. And it's not virtual photons either. Look at the real ones. They're right there. Why do you overlook that? Because it's too easy? I don't know. It's a cognitive bias. In fact, if you simply added protons to those electrons, you'd have hydrogen in there, which is more of a stable, reliable, and proven light pumper, lifting objects in a propellantless manner well over unity with very little fanfare. It's a thing so taken for granted it's going to solve these big questions, and it's right there in front of your face. And that's Not a shot at any of these guys. They're looking too, and there might be something else, and I could be overstating my case. But I do conclude by saying that kind of light-matter interaction is what the shaved ape must perfect, starting with basic improvements on rudimentary metamaterials like what Sonny Drew is holding. Now, Drew, his nickname on APEC is Drew in sunny Florida, so Sonny Drew, that's what that means. And like I said, they're on the right track. They're getting results, but they're not. He's looking for Casimir, he's looking for virtual photons and warp drive and all that, but overlooking the real photons that are right there in the vacuum chamber. The vacuum chamber does not pull temperature out and get rid of it at all, or visible light or any of that stuff. It's still in there. So when you have electrons sitting on a styrofoam thing like Drew has, and he made 300 other versions or something with different materials, or if you have those Townsend Brown spinning gizmos, which I got to see in person, and they do work, by throwing zillions of volts into the what's the heck's that thing called? Capacitors. Okay, and they start flying around and flinging around. Well, that stuff's throwing off X-rays galore, and who knows what else. So those are photons, and you're changing the profile there. Maybe those photons are doing what those Einstein-Eddington refined equations are talking about. They're throwing out these repulsive gravity effects merely from light, which is what an X-ray is. So I hope you're following this. I'm making sense of myself at least. At least I did right there for a moment. So that's all I'm saying. I was supposed to bring that up last time and I forgot. And I want to beat on these guys because it came up in context with this convention that I was mentioning. And then that guy liked that post. I put 2 and 2 together right there at the same time. So I had to mention it while I'm out here. All right, we see the thumbnail again, so that means we're changing gears to something else. What else? Okay, here we come to the part of this humorous thumbnail. Hose Mad Chat. Your glasses could kill you. Shock. That's a bombshell shocker. I mean, look. That's what you're here for, right? Bombshell shockers. So I've been using this, maybe it's tired metaphor, I don't know. People, these photonic signatures that everyone's seeing, and I'm thinking of the Tedesco brothers, but I absolved them before because they're doing the work. They're doing all the work. They can't do everything. And if they hear about gravitational lensing, they're going to say it because smart people are saying it. Avi Loeb or Kevin Knuth and all that. I mean, those are PhD physicists, so, they might be right with the gravitational lensing, and that's what it looks like. It could be that, but instead it's the other way around, inside out. It could also be the exact opposite of inside outness, like we have with Einstein and Eddington and Einstein. Gravity affects light, light affects gravity. So I just used a cheap example with that hydrogen, which is 100% correct, but it does sound cheap. But it's right. Someday people will act on it. When I criticize people saying gravitational lensing, I like to use a cheap example of saying these old man glasses here. Well, I already did that stunt, didn't I? Let's just do it again just to break up the flow here. Give me a little break here. Stick those up there. Look, they're bending light. Oh my gosh. Oh boy, what does that mean? Is that a signature? What is that? Is that high tech? Is that advanced intelligence? Or just mere refraction? Which is what these metamaterials like Gary has in his hand, like I'm telling you about, and just went over a tiresome list of them, that's what they're going to do. They're going to take light, absorb it, and throw it out in some different way. Okay, but we're going to do it in the intelligent way, which causes repulsive gravity, scrambles gravity, discombobulates it, the gravitons, whatever, that is. So, I'm thinking to myself while I'm listening to myself, wouldn't that mean that refraction has some equivalent mass? I mean, if you ask that in physics, probably in college, which has been a long time, the professor might laugh, but it's a valid question. But what would you ever use that for? Why would you ever think of that? Well, here's why. Because if these things are really gravitational lensing, these orbs, let's say an orb, I'm picturing the Tedesco brothers on Long Island. It was a dark and stormy night, but not that stormy that they couldn't see some glowing orbs, and they turn on their machines, and they get a fix on them. And they talk about some really cool effects, the psychedelic and the spinning mirror balls and all that stuff, which makes sense. Plasmonic metasurface. Not plasma, plasmonic. But, so they say, well, there it is, throwing light out in a funny way. And then they said there was some time delays and phase. Time delay, that's right. When we talk about that time delay, I'm thinking, well, you're shooting a radar at a thing, and it's bouncing. The radar gets sucked in and then spit back out. That's the machine not trying to jam you. That's its job. It's set up. It's only a machine. Don't take it personally. But I think they noticed some effect like that, a Doppler shift on something. But why am I going off on that part? So yeah, okay, let's get back to it. Does refraction have anything to do with mass? What really would these old man glasses, what would they equate to in mass? I mean, what's that mean? So, okay, Grok, what do you got to say? Yes, this is a fun and far-out thought experiment. We can actually calculate, etc. and so forth. Then he spewed the calculations. Oh, here's some bold print. That's roughly 5 times the mass of the moon, or 1/15 of the mass of Earth. So that's the mass, 5 times the mass of the moon. But wait. Pardon me. I don't want to burp in your ear. Let me take a drink. Suck in a lot of air talking so much. So Grok says, the quick and dirty metaphor you asked for is, but wait, it would take about 5 times the mass of the moon, yeah, listen to this part, crushed into a speck smaller than a grain of sand to gravitationally bend a light ray passing a couple of centimeters your way by the same angle your reader glasses bend it in ordinary refraction. Now, these glasses are not any fancy metamaterials made out of bismuth and MgO or any of that other stuff. So I'm saying if you scale, and you're with each photon, if you're doing it right, you're creating a repulsive gravity effect or a null effect. Then what happened? You're doing all that. You're not going to need to create. You're not going to squeeze 5 times the mass of a moon into a grain of sand and then stuff a, what do you call it, an orb over Long Island with it. You're going to take the light over Long Island, including the helpful stuff these guys are shooting at you, and you're going to absorb and emit that. And that's what you're going to use. It's not creating mass or weight, but it's the same effect or a similar effect. So it's heavy or it's light as you want it. Lightweight. And that's kind of how I think that's going down over there. So next time you're around your glasses, have more respect for the fact that you're bending space time. No, I'm getting too cute. Too cute. I'll think of a joke for that later. But it just, the bottom line is, do you really think it's gravitational lensing now, or do you think it's just manipulation of light? All right. What's the next bombshell shocker? Oh, okay. This is an aside. This just happened to happen. This is on the miscellaneous. This is not even on the thing I made yesterday, the thumbnail. Now, something happened here. Look at your screen if you're listening. And you might want to see it. It's a piece of floating aerogel. Light hits graphene aerogel. So what? Well, last night, the ESA, European Space Agency, released images about, and a little overview about their experiments in space, and they're saying, wow, look at this aerogel go when it's hit by light compared to how it works on Earth, which is another thing about this light-matter interaction I'm talking about all the time with gravity. Because when you're out in space, you're out there, there's not as much, when you're out there a bit, there's not as much mass hanging around bothering you. Your playground is just gravity and just light. So these things we see on Earth that are greatly enhanced, or these equations, the effects of these things are greatly enhanced when you're out there away from all this mass. So that's what they're doing with this graphene aerogel experiment. And there's a couple of headlines down here, a couple of articles I left here for you, linked below. Where's the real interesting one? Something about 50 times better. Of course, I can't find it. Well, let's just scroll down a little bit and see if it is in here. No. I saw that headline. Where is it? Oh, here it is. The 50 is written in script, not 50. This is from the Quantum Zeitgeist site, it says. And this was fresh off the press right before I started this. Graphene aerogels produce 50 times more thrust in microgravity than on the ground. So all this stuff I'm talking about is going to be blown into more proportion out in space where it's going to be used the most. And again, this is just graphene aerogel. That's not exactly the highest tech metamaterial you can get on Zeta Reticuli. This stuff is kid stuff compared to what you're going to be doing with the bismuths of the world and the magnesium oxides, absorbing and emitting an extreme efficiency and high speeds, repeatedly, endlessly, into the time so fast you can't even imagine it. Femtoseconds, stuff like that, yoctoseconds, and it's happening at the level of angstroms. So you get a lot going on in a little place, and it's going on fast. So, when that scales up, you're going to be tic-tacking it around, in my opinion. So, if you want to do that, you should subscribe, like this channel, follow me on Twitter. So I linked a few what do you call it, posts. And of course, when I saw that yesterday, I'm right in the middle of thinking about how smart I think I am about that other thing. Let's see how smart I was. Okay. And I'm seeing this, and I'm like, this is what I've been saying for quite some time. I used to make these little, well, I've been doing it for years. I haven't done them, don't do as much lately because I'm pretty much doing other stuff. I'm doing videos now. But I used to make these little graphics and post them on, then called Twitter, and my website, which you should also go look at. It's covered with these things. I was obsessed, but I was preoccupied by trying to understand this. To sort of do this, I had to make little images for myself and others. And this is one where, it's talking about light, gravity. Light, gravity, and graphene, or nanotubes, or aerogels. It's all the same stuff, only, organized differently. And I made these little graphics here, linked below. I'm asking myself, when would I do that? I'm going to put that up again. I haven't seen that for a while. And it tells you why. Well, first off, this is from 2018. So when I see something I was talking about 8 years ago, or whenever it was, 8 years ago, and now it's coming to fruition on ESA, in outer space, I'm happy about it. So I'm going to pat myself on the back. Why don't I just do that? See, I admit when I'm doing it. Okay? It's not a humble brag. Is it? But yeah, let me just read this part, though. Nanotube properties facilitate... Oh, this was like sticking hydrogen in there, which you can and should do, because it already pumps light. And then you can... you make... What do you call it? It's called graphene. So it's hydrogen in graphene, which graphene can be stimulated to jack the energy level of hydrogen up and down. You heat it, you cool it. You heat it, you cool it. You heat it, you cool it. It's absorbing and emitting. And that's an easy way to get started on basic metamaterials, in my opinion. It's going to work just like a hydrogen balloon, only intelligently controlled, intelligently built, far more efficient, etc., and so forth. Saying it, and I'm saying it again. What's so great about graphene and nanotubes and aerogels? It's very elastic. It's highly flexible. It's got an efficient aspect ratio. It's got tunable optical structure, high thermal conductivity, very high tensile strength, high electrical conductivity, good electric field emission, low thermal expansion coefficient. So they're inching their way toward it. Don't be surprised if you see exactly that one of these days. And then there's another graphic over here talking about the same thing, only I believe it's leaving the hydrogen out. It's just talking about, well, you can read it yourself. It's almost a poem. Anyway, it was the same time, 2018. So that's a move in the right direction, folks. There it is again on your screen. Now, it just looks like, thing bobbling up there, but it's slowed way down. And that thing that it's doing there is 50 times better than what it would do on Earth. And it's hardly even trying. This is just like beginning of stuff. And I like that picture. This one. It's fun to look at. What's that look like? That looks like graphene surrounded by a cloud of hydrogen. Somehow they're all attached. And you heat and cool that, and it's going to move up and down. It's going to move light through you, in, through, out, and around, absorbing and emitting, creating repulsive. We're going to create our little repulsive things going on with it, and we're going to does it that way, and it also they cancel each other out. So we're going to do some canceling stuff with these light emissions and absorptions. And we can do it anywhere we want because light is everywhere. And all you need is this stuff like what you're seeing on your screen now, which is just an old picture of graphene. Well, you go look at Gary's stuff again, his bismuth, if you'd like. Same deal. Now this post is here, why? Oh, ultra-thin vanadium dioxide films. Okay, I think that's for switching. I thought that was going to be big on our metamaterials list, but it's switching. So that's your switch. You're like, okay, I got a downshift now because I'm coming from 80 degrees Fahrenheit into 100 degrees Fahrenheit. I'm shifting from, I'm coming in over Arizona. Now, where do they crash? Coming in over New Mexico. Kind of downshift to another metamaterial here using my vanadium dioxide shift, and that comes down and all of a sudden it hits a cold spot because there's a lightning storm. So you hit cold, you wipe out, you're spinning around, and then lightning hits it, and then I don't know what that stalls it. I guess I don't know. Well, that screws up the it changes what the metamaterial is supposed to be floating in. Now, it's got a signal going through it telling you it's okay, it's all right. Then it gets hit by lightning. That screws up the bismuth or whatever. All of a sudden, the bismuth thinks it's somewhere else. Starts acting like it's not in Earth's atmosphere, but it's acting like it's out in the coldness of space. And thinks it's supposed to be in gear for -4 for 100 Fahrenheit, but it's really in gear for -452 because it got hit by lightning and that kicked the transmission into park. And now you're stopped, you're smashed, you fell into the ground. End of story. Sad. And this is a random thing here. And I saw this random thing, which may be related. It's called programmable space-time diffraction. Now, what does that mean? And it's linked below. It's one of these scholarly articles that only gives you a short overview unless you're a member or want to pay, whatever. And so it's snippet. I can't figure out exactly what they're getting at. If they're trying to call light space-time, that would be a curious little twist that might happen. Could happen. I think they're just playing word games here. You can read it for yourself. I don't really want to make a fool out of myself any more than I have to. But, there's just something in that about space-time metamaterials and metasurfaces. Okay, that should catch your ear if you've gone this far. And then they add the word diffraction to it. And then programming this thing, and then I think they're talking about what I'm talking about, maybe a microwave band using a transmission reflection integrated programmable metasurface. So they came up with this thing, and it's moving light, and they say, well, if we just call it space-time, we're going to get more attention. Is that what's going on here? I don't know. This is another one that just popped up yesterday. I just thought I'd throw it on here just because. Just because. So, another thumbnail means we are moving on to another topic. Why am I on that? Oh, we're hitting it again. We're hitting it again one last time under the repulsive gravity part of this thumbnail agenda, which we got out of order. Hose mad is last. Anyway, so we're looking at repulsive again, and I believe I already read this to you, so I won't. Yes, I did. Pardon me. More hot air. Yeah, we're just reviewing and I guess emphasizing. Remember, I just saw this yesterday or the day before. This general relativity thing that was buried. And I guess it just struck me again later that they're actually just coming out and calling it repulsive gravity. Let's just read it again, why not? And then we'll be done shortly. After Ho's mad, because they mad Ho's. Tell me, Grok, dumb it down a little one more time for me. Why did I spend all this time listening to this clown on YouTube? What did I learn out of it? Alright, what you learned is, in their 2011 paper called The Gravity of Light, 3 physicists, Sparano, Vilasi, and Vilasi, took a fresh look at this puzzle. Instead of using this usual simplified math that only works for weak gravity, they used the full exact equations of Einstein's general relativity. That's what you were looking for. Remember, we can double it down. I'll say it again. Davis, Weinstein, you were looking for this. There it is. Their big idea was this. When light beams travel through space, they don't just create ordinary gravity. I don't like the word creation there, but that's not right. But anyway, they can also create special nonlinear gravitational waves. I would say they have the effect of it. Of the nonlinear gravitational waves that act like they have a spin 1 property. In quantum picture, this would be like a massless photons. So in other words, in plain English, they are discombobulating the scenario. These spin 1 parts of the gravity wave can't be removed or ignored by choosing a different mathematical gauge. Okay, that's science talk saying this is why we wrote this, guys. And gals, come at me. And they create a repulsive force in certain situations. I hope I didn't pop the mic out too hard saying repulsive force, but that's what it is. Especially when 2 light beams are moving side by side in the same direction. See, I'm going to have to dig into this. I can almost visualize and eyeball it with the spins 1s and spin 2s in my mind. It's just things, well, like they said about the charges. It's things that just, they're opposite of each other by nature. So they repulse each other by nature. And we're going to take that and use that phenomenon. That repulsion is exactly what explains why the old calculations showed no attraction between parallel light beams. And I do remember that from way back, maybe even in college physics, that was always an anomaly of some sort. Why didn't that happen? It was a mystery. And man, I think if I have a brain cell left with the mass of 5 moons in it and a grain of sand, and that's how I can barely remember that. But it's coming up as an old memory. Like, that was always a mystery. Why was there no attraction between parallel light beams? And it's got to be that it's discombobulating, and that's what we want. So what are we going to do? Send out a lot of parallel light beams, I guess. Why not? Okay. And then, we dumbed it down even more. Yes. We're going to reread it even more and get out of here. One more time, because it's worth it. That's why you're here. Hold on one second. I need to sip. And we are rereading. But this is to drill it into your head and to drill it into mine. You can log off if you don't want to hear about the hose. In their 2011... Yeah, wait a minute. I asked for it even simpler. Yes, here's an even simpler. In their 2011 paper called The Gravity of Light, 3 physicists, Sparano, Vilasi, and Vilasi, took a fresh look at the old puzzle. Instead of using the usual simplified math that only works for weak gravity, they used the full, exact equations. That's bold. And that's what we're learning here, of Einstein's general relativity. Their big idea was this. Now, I know that's repetitious, but this is the dumbed down version, so that we can remember the big idea. When light beams travel through space, They don't just create ordinary gravity, they also create special nonlinear gravitational waves that act like they have spin 1 property in a quantum picture. This would be like massless graviphotons, which I kind of think I know what they're saying. They're spinning around, they're flipping the gravitons. And that makes them look like it's hard to say this. Makes them configured more like a photon. You take two, I can see it in my mind's eye. You take two like things and you turn the other one, twist it, so it's exactly unlike the first thing, then it's photon-like. Which when you get into these spins, that makes sense. Anyway, these spin 1 parts of the gravity waves can't be removed or ignored by choosing a different mathematical gauge. That's technical talk for you math guys. And they create a repulsive force in certain situations. Now that's what I can understand, especially when two light beams are moving side by side in the same direction. So that's going to do something with that. That repulsion is exactly what explains why the old calculation showed no attraction. Okay, we did this between parallel light beams. It's not a mistake, M-. It's a real effect hiding in the full nonlinear theory of gravity. Now that's dumbed down nicely for me. It's in there. What it's saying is it's in there. So that's your breadcrumb. You want a bigger breadcrumb than that? You got one? I don't think so. So that was our point to all this. Now we have a little postscript, hose mad chat. Now I heard this, it made me laugh, from Ashton Forbes, and then I'm looking at UFOX, formerly known as UFO Twitter. And you have to be on there if you're paying attention to all this stuff. It's all mixed up. You can't ignore the gossip. You can't ignore... you can't. Maybe you can. Maybe other people can. And then there's the political side to it. Okay? We live in the world, folks. We live in a society. So I see this. This is regarding disclosure. In other words, disclosure by the government of secrets, facts that UFOs are visiting Earth, or there are aliens, or both. One kind of implies the other, and vice versa. So is that going to happen because of Trump? And we can give Obama credit for bringing it up, mentioning it. I mean, it's almost nonpartisan, almost. So I'm partisan. I wish I could keep it out of this, but it comes up now and then. And when I see something, I say something, because if you don't, they'll just go on, and they'll think that there's no one disagreeing with them, and they'll think that they're on the Twitter of 2016 instead of the X of 26. And they're going to say stuff like this, which I don't go looking for it, folks. But when I see it, I got to say something. And here's a guy, Swiss Army Uber, and I think in general, I recognize the name Strader, and I read what he has to say when I see it, because he has some good thoughts on this topic generally, I believe. That's why I read it, and I was like, oh, Strader, what's he saying? It's official. I do not want disclosure by Trump. Keep your mouth shut. When you open it, bad things happen. I've waited for over 40 years for the truth to come out. Wait a minute, let me just ham it up a little bit here. I waited over Trump. Well, Biden had his chance. All right, let's go back. Where was I? Yeah. So I see this, minding my own business. I'm willing to wait a little while longer. This president doesn't deserve the right to tell us. legacy matters. Okay, you tell me what matters. All right? Yeah. You're the authority, Swiss Army Uber, on what matters. So I had to answer him with this. Look at your screen, and you'll see my answer to that kind of stuff. Hey, little buddy, have you considered crying about it with a grinning Trump? Now, you can hate him all you want, whatever, but if you're going to put stuff out there like that, people are going to make fun of you, like I just did, and disagree. And I'll say this for him. He didn't block me, so that's good. You know, that's an improvement over a lot of morons out there. And, you know, I listen to YouTubes as well. And there's this crew called Night Shift, and I tuned into them on Friday sometimes if I'm running out of stuff to listen to, which I did. And it was live. I tuned, you know, I'm out walking around, I'm hiking, I'm getting my cardio in the park on the hills. And these guys start crying about Trump is not empathetic. I wish he was dead. I mean, this is the kind of moronic stuff that's just not going to go unanswered. You can head bob with yourself and like your tweets all you want, but not everyone agrees with you, and some of us speak up about it. So that's all that. That's all I had to say there. Hoes mad. Hoes mad. If I could say it like Ashton, I would. Hoes mad. Hoes mad, chat. And so there's a little goading. But, hey, man, you put it out there, you're going to get it back. All right, ladies and gentlemen, we're done. We're done with our bombshells and shockers. Let's see what time it is. Oh, an hour and a half. All right, that's not too bad. That's good. That gives me a little time to do stuff before I got to do stuff. So I want to thank you for tuning in. Don't be too mad, hoes. Okay? Don't be too mad. Don't be too mad. Rent-free. You're losing money when the guy's rent-free. So here I am again, waving goodbye, signing off. See you next time. I hope you did learn something about that. I don't mean to goad too many people, but if they're goading me, they're getting it back. So we'll see you later. Bye-bye.